as I said in the last video, now we are going to focus on scenario-based questions, and we are going to simplify the Boolean expression and then come up with the digital circuit solution or the logic circuit solution by using K-maps. Okay, so let's read the question. A factory safety system uses 4 sensors A, B, C, D. The system triggers an alarm F is equals to 1 if any 2 or more sensors are active simultaneously, indicating a potential hazard. Okay, now first of all, when you are facing scenario questions, the first step won't be, finding the Boolean expression. We have to focus on the table first, because if you don't have the truth table, you can't actually come up with the Boolean expression. So for scenario questions, the rules change a bit. So first of all, you have to come up with the truth table, and that's what we are going to do. Since we have A, B, C, and D, we need 16 combinations, right? Because 4 bits, that means 2 to the power 4, 16 combinations. So let's insert a table. Okay, I'm going to insert a table. So it will require obviously 5 columns, Y, A, B, C, D, and then output X. Then we will have number of rows as 17. Okay, so that's what we have here. Now we have all 16 combinations for the 4 bits. The condition is the system triggers an alarm F is equals to 1 if any 2 or more sensors are active simultaneously, which means 2 or more inputs should be 1 at the same time. That's the idea. So if you look at this, the first one, all 4 are 0, so the output will be 0. Only 1 is 1, so the output will be 0. Similarly, here also only 1 is 1, output will be 0. Since 2 or more sensors, since there are 2 inputs as 1, 2 are 1 inputs, so we'll put 1 here. Similarly, here 0, here 1, here 1, here 1, here 0, here 1, here 1, here 1, and other than that, everything will be 1. So there are totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 minterms here. So it's going to be a big Boolean expression. Okay, so it's going to be a big Boolean expression. So let's first of all write down the minterms. Now we can come up with the expression. So the first step was coming up with the truth table. The second step will be finding the Boolean expression in SOP format. Why? We are using minterms. Minterms means SOP. Maxterms means POS. That's it. So let me come up with a solution. You can try in your own time. Pause it and do it. Then look at the answer. Because there are nearly how many terms? 4, 8, 11 terms. So you have to be very careful when you're writing this down. So this will be the final answer for the second step. Yeah, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 minterms. Now we are going to the third step, where we will use the K-map to plot down these specific combinations. Since there are 16 bits, we normally use 4 by 4 rather than 8 by 2 or 2 by 8. So let me draw the K-map here. Now let's name the directions. Since we have A, B, C, D, I'll put A, B here and then C, D here. Now let's write the orders, okay, the column names first. A bar, B bar, A bar, B, A, B bar, and finally A, B. Actually A, B bar, here A, B will come. So let me erase this. Alright. Now we have C bar, D bar, C bar, D, C, D, and finally C, D bar. Now we have to plot these minterms here. So A bar, B bar, C, D. So 1 will come here. Interesting looking one, but let's count it again because we have to make sure we have 11 minterms here. So 1, 3, 4, 7, and 10. We are missing, no, 1, 3, 4, 8, 11. We have the 11 inputs correctly. We have marked the 11 things. Now, what are we going to do? Well, the next step is going to be interesting. Why? We are going to do the simplification. Since we are using K-map simplification, it will be pretty easy. So let's go to the fourth step. We have to, first of all, we have to do something called grouping. So how are we going to group this? Well, we need groups of 8s, 16s, 4s, 2s, or 1s. So let's look for 8s. Do we have 8s? No, because there is a 9, But this 9 is not what we are going for. Why? 9 is not allowed in K-map grouping. So what do we have? We actually have only 4s. Okay, so let's go for 4s. So if you look at it, we have a 4 here. We have a 4 here. And then we have a 4 here also. We will use this 4 also because overlapping is allowed and we only go for the largest groups, the groups with highest number of units or cells. And it's the same here also. So we already have 4 groups. Now you may think we can go for something like this, but no. Here also we have a 4. Here also we have a 4. Similarly, here also we have a 4. Here also we have a 4. So totally we have 6 groups. Okay, totally we have 6 groups. Just because we have 6 groups, we are going to name every single one of them. Okay, why? Or else we will get confused and we don't want that to happen. Then this is the problem we face when we have more variables. That's the thing. Okay, that's why we normally stop with 4 variable questions when we are practicing this. If you go for 5 variables, wow, it will be very interesting. All right. Now let's go with the first group. Okay, first group we have AB and AB bar. So we know B will be cancelled, and this is spanning across two rows also. So C and C bar will cancel each other out. So we will have D. So this will correspond to AD. And the second group will correspond to the same thing, right? A will come, and here D and D bar are going out. So we will have AC. And here we will have B, and then D and D bar will cancel each other out. So we'll get C. And for the fourth group, okay, I'll write the fourth group separately here. Fourth group, A bar and A are there. So they will cancel each other out. So we will get B. And row wise, we will get C and C bar cancelling out. So we'll get D. And for the fifth group, this is column wise, right? Directly one column is there. So AB will come. If you do one by one, they will cancel each other out. Think about it. D bar and D will cancel each other out. D and D bar will cancel each other out. This C and C bar will cancel each other out. C bar and C will cancel each other out. It's the same for sixth one also. I'll write the sixth one separately. So here we have row, single row. So only CD will come. Okay, that's the idea. That's what you get. So let's simplify this. F will be equals to AD plus AC plus BC plus, well, fourth one is BD plus AB plus finally CD. That's it. Now what we are going to do, the final step, we are going to rearrange this so that we can only use one specific universal gate. There is NOR gate and then NAND gate. Here we will be using NAND gates. Okay, since we are using min terms, we will use NAND gates. For max term, we will use NOR gates. So if I rearrange this, we will get AD into AC into BC into BD into AB into CD. But everything will have a whole thing bar, and then these will have a whole thing bar. Beauty of this is we don't have any A bar or those things. So that's a good thing. Interesting. And since there is no A bar or anything, we will just need 7 NAND gates here. So let me draw this. First of all, let me come up with the, A, B, C, D input lines. First of all, A and B require a NAND gate. So let's give them a NAND gate. And then A and C require a NAND gate. So let's give them also a NAND gate. And then A and D require a NAND gate. So we will give them also a NAND gate. And then B and C require a NAND gate. So we will give them a NAND gate. Since you know the pattern, you will also know B and D require a NAND gate. So we will need bigger lines here, input lines. So B and D will require a NAND gate. We will give them a NAND gate. and then C and D will require a NAND gate. We will give them a NAND gate too. And these will all go inside a single NAND gate. That's it. Now we will put them inside a single NAND gate, and we will have our output, which will be F. Thank you for watching the video on 4 input minterms K-map simplification. I hope you enjoyed the video and learned something new, and I will meet you in another video. Until then, keep learning and stay curious.